We'll continue the same of the direction of the archaeology. And in my report, I will speak about the pottery, archaeological pottery. And I will try to distance from the origin, from the area where the pottery was made, and we'll tell about the pottery as the material, the kind of material. And what is a pottery? This is a type of ceramics that made from the natural clay. And what is a clay? Clay minerals are the aluminosilicates with some addings, natural trash in any cases, weathering products, and it can be very many different additions. And also the pottery is a kind of, as we call now, it metamaterial, because special masters were taking some raw material, did some preparation, did some thermal steps, firing it, and we're taking a special material with some special properties. I will talk about the kitchen pottery and food pottery. It means some vessels, not the ceramics for the building purposes. Why is it so interesting to investigate the ancient pottery, archaeological pottery? Because this is the most common, most often finds in any excavations since the Neolithic period, and it continues up to our nowadays. So it's quite interesting. And now I will show you the samples. This is some examples from regular photos, how it looks like. Maybe you can see, maybe not, that here some dots, microscopic includings. They can be black colored, white dots. It can be sand. It can be some stone particles. It depends on the area where the pottery was made, and also depends on some purposes of the metamaterial of the vessel, or in case of the building, for the building for the stone properties, bricks properties. This is the magnified photos of investigated samples, and in this work we are investigating 6 samples. Here you can see magnified photos of the 5 original archaeological pottery. It was taken from one of the museums in Russia. And the question from the museum staff was, can we combine it? Can we see some differences or any properties for the combination or to different these types of pottery in up to 3 groups. And they also give us special sample, modern sample. It was made in 1 or 2 years ago by the museum staff during the experiment. And they tried to do it in the same way as the ancient masters, as they think, of course. Original clay, the raw clay, was taken from the same clay pits or clay deposits. I don't know the right term in English, sorry. And they tried to add some inclusions for the receipt of the past as they think, as ancient masters did it. And I will show you some preliminary results. Here is the hysteresis of this all 6 samples, and we can see that the modern sample, red colored, shows a bit ferromagnetic properties, but oops, what was it? But the whole set shows the not the ferromagnetic exposable. Paramagnetic, sorry, properties. What we know about the origin of this material? This is the alumosilicate, and of course it consists some ferrum, natural ferrum, in the regular amount. It can be up to 6%, but this is both 2 and 3 ferrum, 3 plus ferrum. So this is, it can consist also ferromagnetic and non-magnetic iron in it. Also, we did XRF, but it was made on the spectrometer from the Learning Research Center. It's for the center for the study for laboratory works for the students. So this is the first way, but in this way we cannot see a lot of elements because the survey was made in the air. So we can't see the oxygen, we can't see elements from the light elements up to lithium, right? And you cannot see rhodium because it has a rhodium tube. And on top, on this table, the main composition of the samples, of course, it's silicon, aluminum. Of course, here we can see iron. I don't know yet what can we say about the potassium, and we can even by XRF results say that we can see some groups of presence or absence of some elements The next step was the NMR, mass NMR. Here you can see spectra for the hydrogen, and I can see that there is some differences, and we can see here also the water. It's a very good question about the water in the pottery, because while the pottery is making its firing, often it's firing in extremely high temperature, up to 1100 degrees by Celsius, and this is also a very interesting question. What was the firing temperature of that piece of pottery? But it will be further. Here, I think that we have the water, because these pieces of pottery were spent up to 2000 years in the soil, and they were in contact with air, with a lot of materials, and of course it's porous alumosilicate. Now it contains some water. The next step will be the remeasuring after the heating, but here is the first step only, and we can see that we can try to combine or in difference also by the mass NMR spectra in 2 or 3 groups. Here is aluminum spectra, also very interesting, and we can see that here we have more differences. Lines are changing more than in hydrogen spectra, and at last the silicon spectra. It was measured without coupling, so we have a lot of noise here, but also very interesting, especially this spectra of the first sample differs from all others. It's also very interesting, and here we can see one line, and now we will try to understand what we can see here and what can we have from NMR method, and we can try also to repeat some results from our colleagues. I announced it in my thesis, but it will be later in the next steps. So that's all.
So I think unless there are some pressing questions, we'd better. Sorry, I will go.
I have one question concerning your broader spectra. You did MRS spectra. You do MAS, of course, to narrow the lines. But we have a very, very broad line there and superimposed over the narrow lines of the water. And this background is very different on all these. You have an idea where this comes from?
It's not the whole spectra. It's on the central piece. It also has a big plateau. And yes.
Or are the spinning side then?
The spinning side was the same. It was 10 kilohertz. The temperature was the same. The room temperature, 30 degrees. It was a very warm room, and the same conditions for the same nucleus.
Yes, they do appear at around 10 kilohertz where you expect to see the spinning side bands. Is that about right or not?
It was chosen after reading one of the articles where our authors were investigating maybe similar material, and it was very good. Has a very good review and very good explanation of the experiment. We just took these conditions and we saw that it works, and in first step we tried to do it. So we can see that we can have good enough results for these conditions. Of course, we will try to make steps to the left and to the right. We'll try to measure temperature with a different temperature, with a different angle spin, and of course it will. But it's only the preliminary results and the first step.
Thank you very much.
You're welcome.